Hello and welcome to another episode of James and Chris Science Videos, where today I'm going to be looking at acids and the pH scale, and we're going to look at that from the Keystage 3 and Common Entrance syllabus to hopefully make sense of it and to give you a better idea of what acids are. So we're going to start off with what an acid is, and in order to explain this I'm going to go a little bit beyond the detail that you need to know. I mean, you're not going to need this for the exam, but in order to explain acids it's quite useful to know. Acids are all about hydrogen, and more specifically more about something called hydrogen ions. Now, what does that mean? Well, a hydrogen ion is the nucleus of a hydrogen without its electrons. Now, we don't need to know much about that at the moment, but what you do need to know is because it can do that, hydrogen will react and form bonds with non-metals. And it's when it does this that it forms an acid. An acid is that hydrogen ion bonded with a non-metal. So what you can see here is, here's a periodic table and those yellow elements on the side. Now I should point out it doesn't include the noble gases, it doesn't include helium, neon, argon, krypton, xenon and radon because they won't react with anything. But you do have the yellow, which is carbon, nitrogen, oxygen's a bit special, we'll come to that in a minute, fluorine, chlorine, bromine, iodine and sulfur, phosphorus are all there. So those are the things that will make acid. It's going to be hydrogen with one of those in some kind of combination. So the first time we're going to look at this, the naming of acids is quite specific. There's two ways of naming it. One is where you put the word hydro in front, and the second time is where you don't, and what that means. I'm not going to go into organic chemistry, that is something separate for GCSE and A levels. But at this moment, the two types of acid you need to know have either got hydro in front or don't. So we're going to start with the hydro acids. And this includes the hydrochloric acid, which is one of our main laboratory acids. It's also what's inside your stomach. It's what helps fight germs when you swallow food. So its formula is, and I'm going to put this here on the screen, HCl and then brackets AQ. We'll come to that in a second. So what does that mean? Well, the H means that there's one hydrogen atom. The Cl means there's one chlorine atom, and the AQ means aqueous, which means you have to dissolve it in water for it to work. So HCl brackets AQ means hydrogen chloride, its technical term, dissolved in water to form that acid. Now I've put at the bottom there, will form a chloride. That's going to be quite important. We're going to come to that when we talk about the reactions later. Here are some other examples. We've got some hydrofluoric acid, hydrosulfuric acid. I've put down it exists. It's not the same as sulfuric acid, that comes separate and we're going to look at that later. The summary of this little section is that if you've got a hydrogen in its name, so hydrochloric, hydrofluoric, then it's going to be hydrogen with one non-metal on its own. There's going to be nothing else, it's going to be hydrogen and that non-metal. That's how we name it. Right, so moving on to the second type of acid is the non-hydro acids, and these are things like sulfuric acid, nitric acid and so on. So the naming no longer has the hydro in it. But if we look inside the molecules, here's a formula of sulfuric acid, H2SO4. Can you see it's again hydrogen, and this time it's with an 8 group, this case sulfate. So again, we've got two hydrogen atoms. I've got that sulfate group which contains oxygen as well, and that's going to be dissolved in water to enable it to work. So when we look at the naming, we've got two types. The hydro acids, hydrochloric, is going to be hydrogen and just the chlorine. You could have chloric acid, I suppose, which would be hydrogen, chlorine and oxygen. That's how we would name it. Whereas if it hasn't got hydro in it, then you know you're dealing with something with oxygen, so that would form an 8 group. So we've got two types, one with oxygen, one without, and you can tell it's got oxygen if they drop that hydro from the name. So here's some other examples. We've got sulfuric acid, was the one we just looked at, nitric, carbonic and ethanoic. Again, you can see each of those. There's the hydrogen, and in this case there's an 8 group, a nitrate group, a carbonate group, and the ethanoic acid, that's actually called ethanoate, that's just another group of elements joined together. So how do I know I've got an acid? Well, to find that out, we've got to use indicators. And indicators are chemicals that will change colour if an acid or an alkaline, we're going to talk about alkalis in another video, is present. It's kind of the opposite to an acid. So the two that we need to know for the Common Entrance syllabus is litmus. And litmus is very easy. It's only two colours. If it's in acid, it goes red. If it's in alkali, it goes blue. And this can be in paper version, or it could be in liquid version. You can put a squirt of it in, or you can put the paper in. Lots of vegetables and fruits also do these colour changes. Red cabbage is a good example. I've put in the bottom a picture of the changes that they'll go. Now those numbers we're going to talk about in a separate, that's something called the pH scale. Cherries and blueberries also work. There's lots of fruits and foods that do change colour. So the main indicator we use though in a laboratory is a universal indicator, and for that we need the pH scale. So this again can come in paper form or liquid form, and it is a range of colours that go from red all the way up to purple that are linked to numbers. The numbers are called its pH. So if we look at this a little bit more carefully, the H, by the way, is a hydrogen ion. So that goes back to the hydrogen being the key part of an acid. So here is the pH scale going from 1 to 14. And we start off right at the bottom. That number 1 represents the strongest acids. So that could be hydrochloric acid. I've included a picture of a stomach just to prove again, well, to show that it's the stomach acid that you have inside you is hydrochloric. We then go up to 5 and 6, and that would be our weaker acids. So 1 being the strongest, the further you go to 1, the stronger it gets. 6 is the weakest acid you can get, with 7 being neutral, not acid or alkali. So water is pH 7 and would sit right in the middle. When we go the other way, we get our alkalis. Now, our alkalis are used as cleaning products quite a lot, and we'll see some of them in a future video. But as you can see, as we go further away from 7, we get stronger, and that's in both directions. So if I'm going down from 7, I'm getting stronger acidic. If I'm going up from 7, I'm getting stronger alkaline. So we can look at that and see how strong our acid is, which is quite important. So we now need to look at some of the reactions we can do with these acids. And I'm going to talk you through stage by stage of how to work them out, because as a chemist, you need to be able to work these out, not rely on memory. I think a lot of people go to the exams thinking, I must know the answer to this equation, where that is not the case. It's a case of working it out. So the 4 acid reactions we need to know, I'm going to whiz through very quickly. And I'm going to talk about the first one in depth, and I've kind of covered the other 2 in separate videos, so I'll brush over the last 2 quickly. So my first one is where we've got metal plus acid reactions. The example I've given is magnesium plus hydrochloric acid. And a nice little picture there of a test tube. You can tell a reaction's going on because it's effervescing, it's bubbling. And we can make some predictions about what the gas is going to be formed. But to show you this, I'm going to show you this in a bit more detail. So here is the equation. I've got the reactants, magnesium plus hydrochloric acid. And that is going to turn into the products. I've put the formula below, and I should point out at this point that formula equations you don't need to do at this level, but I find it useful to show what's happening because the formulas show us what atoms inside. So our first stage, it's going to be very much like a displacement reaction. The magnesium is going to steal the chlorine away from the hydrogen. So where we started off with magnesium hydrochloric acid, you can see that the magnesium has stolen the chlorine to form magnesium chloride. And this technically is called a salt. A salt is a metal and non-metal joined together. That would be a salt via ionic bonds, which you'll do later. Now, I have also put on, you don't need to know why it's MgCl2 and not MgCl. That's something that comes later, and we're not going to cover that as part of Keystage 3. So I look at that, and I've got my magnesium and my chlorine forming together, and that leaves me the hydrogen on its own. And you can see that if you know what the acid is, you can tell straight away what you've got as products. It's going to be the non-metal part of the acid forms the salt, and the hydrogen is always left to form whatever's left over. So in this case, just hydrogen, and that's why we get bubbles. So the second type of reaction we need to do and look at is if I had a metal oxide with an acid. So in this case, I have put down magnesium oxide plus sulfuric acid. And again, we'll talk through the process again. It's useful to put the equation down. It's useful to put the symbols and formula down because, again, we can see the number of atoms. So in exactly the same way as last time, my magnesium is going to steal from the hydrogen. Now, in this case, the sulfate group will stick together. The group that goes with the acid tends to stay together most of the time. So we got magnesium plus sulfate would be magnesium sulfate. That again is a salt. But now we've got a problem. Before we had hydrogen kicking off, but this time, hopefully you can see, you've got hydrogen and oxygen left. And so those are going to combine to give you water. So if I reacted magnesium oxide and sulfuric acid, there would be no bubbles. It would just form water and it would just look like a liquid. All we could tell if there's a reaction was probably just the change of colour. And we would probably need an indicator in there to tell us when we'd reached a neutral point. Now, the other two reactions that we need to look at are alkali plus acid and metal carbonate plus acid. The metal carbonate plus acid I covered in detail in the limestone video. So if you want to look that up and see more detail about that, that is in the limestone. The alkali and acid one I'm going to cover in a video about alkalis on their own. But the two are there, and hopefully you can work out using some symbols why the products are salt and water for alkali and acid and why they are salt, water and carbon dioxide for the metal carbonate reactions. Okay, so thank you very much for watching. Hope to see you soon. Bye bye.